Alright, so today we're going to look at lesson 1.7, and that lesson has to do with connecting quadratics to polynomials because we've been talking about polynomials for quite a while now. So our learning objective for today, or for this lesson, students will graph with Desmos and identify characteristics of quadratic equations written in standard form. Okay, so let's move on. All right, so let's try to remember this. So if I look at these polynomials that I have here, I want us to try to determine what is the term and the degree of each one of these polynomials. Okay, so for the first one, we have x squared. So what is the degree of just the polynomial term of x squared? That's right. You have one term there, and the degree would be 2. So let's look at negative 3x squared plus 6. All right. So in negative 3x squared plus 6, we have 1, 2 terms. All right. And again, our degree is 2 because that is our highest exponent. So the degree is 2, and the number of terms we have is also 2. All right. And last but not least, looking at 2x squared minus x minus 12, we can see clearly that we have one term, two terms, and three terms here. And also the highest exponent here is 2. So this one also has a degree of 2. Now, what do we notice? Okay, when it comes to the three polynomial expressions that we were given, what do we notice about all three of them? Well, you probably noticed that they all have a degree of 2, which means that is the highest exponent in each one of those polynomial expressions. Okay? So, that's right. They all have the degree of 2. All right. Any polynomial with a degree of 2 says the polynomials are quadratic. Okay? Quadratic. All right. Different ways quadratics are written. Well, first of all, they can be written in what we call standard form. And so if it's written in standard form, then it should look like ax squared plus bx plus c. We also have what we call vertex form, which is a times x minus h squared plus k. And last but not least, we have factored form, which is x minus a and x minus c for this case. And this is just these are just generic forms, okay, of each particular form that we're looking at. But if we notice, they all have the highest exponent of 2. Now, for the factor form, you probably say, well, I don't see an exponent of 2 there. All right, and we'll talk a little bit more about that when we get to discussing factored form. All right, so now if we want to graph these quadratic polynomials, we must write them as equations. All right, and if you remember correctly, what makes something an equation? Setting it equal to something. Okay, having that equal sign makes it an equation now. So as you can see, I took the equation or the polynomial expression that was written in standard form and I made it into an equation by setting it equal to y. All right, I can also make an equation with the factored form and I set it equal to y. And I also made an equation with the vertex form and I also set that equal to y. So examples of what standard form would look like would be y equals 2x squared minus x minus 12, as in the previous example that we did when we first began. If I notice and I remember, if I look up here, this is standard form. So you can see that in the A position, I have a 2 that is currently there. In the B position, well, there is technically no number there. And since there is no number, technically we assume or we say that is a negative 1. All right. And then for C, which C is always the constant term or the term that's in at the end, if I write it from highest degree to lowest degree, This is the term that doesn't have a variable on it at all, and that one is negative 12. All right. Then we have this factored form, okay, and you can see the values that I placed in and substituted for A and C. And then last but not least, we have vertex form, and you see values that I substituted in for A, H, and also K. All right, so today we're just going to focus our learning and attention just on working with the standard form for right now. All right, so with the standard form is written as y equals a times x squared plus bx plus c, where a, b, and c are what we call real numbers. But a cannot be equal to 0. This is very important that we understand that. So a cannot be equal to 0 if it is a quadratic equation. Now, some of you guys probably thinking, why can a not be equal to 0 if it is quadratic? Well, let me show you. So if I substitute 0 in for a here, watch what happens to now this a term, okay? Or watch what happens to our highest exponent. That's right, it disappeared. So therefore, since the highest exponent is no longer 2, that means that this wouldn't be quadratic. So if a was ever 0, then it wouldn't be a quadratic equation. So therefore, that is why a cannot equal to 0. All right? So, would this equation still be quadratic? Absolutely not. And we have already noted that it can't be quadratic because it would take the degree away from here. All right, so let's move on. So now what we want to do, we want to look at some examples of some quadratic equations that are written in standard form. Okay, so if we look at the first equation that we have here, this is y equals 2x squared minus x minus 12, and it's written in standard form. So we want to be able to identify our a value. And so if I look here, the a value is always connected to the squared term. All right, so in this case, the a value would just be the coefficient of that x squared term, which is 2. So the a value here would be 2. All right, what about the b value? The b value is always connected to the x term. And as you can see here, there is no number written here. So this b value is understood to be negative 1. All right, and lastly, our c value, which is the last value that doesn't have a variable on it, would technically be negative 12. All right, let's look at another example. All right, so we have y equals negative 3x squared plus 6. All right, our a value would be negative 3. Now, what do you notice or what do you think about the b value? That's right. There's no b value there at all. So what do I put when I don't see a b value? 0. Right, because there's no b value. All right, and the c value would be the positive 6. All right, so now let's look at one more equation. So in this equation, if you'll notice, it seems like I only have possibly an a value. So what would that a value be? Positive 1. Very good. Now, where is the b value? Oh, I don't have a b value, so therefore the b value would be 0. And the c value, I don't have a c value, so the c value would also be 0 as well. Okay, now we've kind of hit some basic information regarding these polynomials that are written in standard form. And we also understand and know that these polynomials can also be written in vertex form and factor form, but we're focusing solely today on standard form. So now let's graph some of the equations, okay? So let's look at the equation of y equals 2x squared minus x minus 12. And we're going to graph that using Desmos. Okay, we're going to use Desmos. All right, so now we're going to go to desmos.com so that we can plug each one of these equations into Desmos and get some information from using Desmos. So we're going to click on where it says Graphing Calculator. And it takes us to a page that looks like this. So we're first going to plug in our first equation, and it is going to be y equals 2, sorry, that should be 2x. Now, if you come down below, okay, there's a little keypad that sits below there where you can find some of your math symbols just in case if you don't know how to find them on a calculator. So 2x squared minus x minus 12 is the first equation that we're going to put into Desmos. Now if you look here with Desmos, I can take this and I can move it around however I want to. I can zoom in. I could also zoom out with Desmos, but uh, you can kind of play with that to kind of see what Desmos would allow you to do. But here is the great thing about using Desmos to help you to draw or to get information for these quadratic functions. Not just for these quadratic functions, but for any type of function that you're trying to graph. So first of all, the first thing is asking me to look for the x-intercepts. So to find the x-intercepts, I know that the x-intercepts is where the graph crosses the x-axis. And I can see that at this mark, there is an x-intercept because there is a dot directly on my x-axis. And also at this mark, there is an x-intercept. So the neat thing about Desmos is that when I click those in place, it stays there. All right, so what I'm going to do now, I'm going to take this information and I'm going to transfer it over onto my document here. So I see that the x-intercepts, I have two of them, and one is at negative 2.212, and the other one is at 2.712. Okay, and those would represent my x-intercepts there. Okay, now the y-intercept. If I look over here very closely, because I'm noticing that there are 2 points there. So you got to make sure that you click on the point. If I come down the y-intercept, and I know that's where it crosses the y-axis, and so this dark vertical axis here is my y-axis. So I click on the point that is going through that axis, and I get 0, negative 12. So over here, I know that my x-intercept, or it crosses the x-axis at negative 12. Okay, next we're going to come through, and we've talked about this already, talked about the line of symmetry and how the line of symmetry basically goes through the vertex. So since the line of symmetry goes through the vertex, and we know that the vertex is either the highest point or the lowest point, I'm going to click on this point right here, which is my vertex, and it shows me that the vertex is at 0.25. Let's write that in here. So 0.25 comma negative 12.125. Okay, I'm going to just fudge that in there. Now, you probably said, well, you didn't put the axis of symmetry first, but you put the vertex first. There's a reason I did that, mainly because if you know what your vertex is, then you know that your axis of symmetry is going to be your x coordinate, okay, of your vertex. So in this case, the x-coordinate of the vertex is 0.25. So if I was writing the axis of symmetry, it would be x equal, as we learned in the previous video, be x equal 0.25 or 0.25. All right, so as you can see, just from graphing the equations in Desmos, we were able to kind of obtain quite a bit of information just from the graph using Desmos. All right, so let's try the next one. All right, so I'm going to exit this out, and I want to go to Desmos, and I'm going to click and type in the new equation. So the equation is y is equal to negative 3x plus 6. All right, and as you can see, this is a little big on my screen, so and I forgot the square. That's why it looks like that too. So we'll put the square in. All right, so here we go. So now we got this quadratic equation, all right, where it looks like the U, and we talked about this before, and I noticed that there's my x-intercepts right there, and I have 2 again, and then I have this point, which it looks like my vertex, but not only does it look like my vertex, because this particular point is my vertex, but it also lies on my x-axis. So in this case, the vertex and the, not my x-axis, I'm sorry, the vertex and the y-intercept looks to be the same. So let's run through this really quick. So our x-intercepts, we've already said that they're going to be negative 1.41. Okay, that's one of them. And my other x-intercept is going to be positive 0.41. I think there's a 4 at the end. I missed that 4. Okay. All right, so those are my 2 x-intercepts there. All right, now if I go to my y-intercept, you'll notice that my y-intercept is this point right here. But some of you guys might say, well, that seems like it's the highest point. Well, it is the highest point as well, but it's also on the y-axis. So since it's on the y-axis, I have to call this point, which is 6, is where it crosses the y-axis. And then I also notice that the vertex is that highest point where it crosses the y-axis. So this is at point 0.06. All right, so the axis of symmetry. If we recall or remember from the last example that we did, the axis of symmetry is always the x-coordinate of the vertex. So I create an equation, x equals 0. And I want to just show you this time that x equals, because anytime we have an equal sign, it creates an equation. So if I come over here and I type x in, I'm going to type equals 0, you're going to notice that this green line is formed, which splits the parabola in half, which is the axis of symmetry. Remember, because that's what the axis of symmetry is. It cuts the parabola right in half. So when I put that equation in, you guys were able to very quickly see that. Okay? Now, I'm going to leave it here because I want you guys to try this on your own, and we'll discuss it. So make sure that you go to Desmos.com so that you can begin graphing this equation like we did the last 2 examples there.